All right, let's start talking about things that affect reaction rates, things that can speed up or slow down your reaction. All right, so we already went over collision theory, right? They have to collide, they have to be in the right orientation, they have to have enough energy. Okay, yes. There's something called the collision frequency, right? That's just like how many collisions you're having per second. So, but there's also, of those collisions, how many are in the right orientation with the right energy. That's what we mean by collision efficiency. So the rate of reaction depends on the collision frequency of the reactants and the efficiency. So how many of those things would be in the right orientation, right energy? Kind of beyond all that, there's like nature of the reactants. We have surface area, temperature, concentration, and whether or not you have a catalyst involved. Those can all influence the rate of your reaction. I want to talk about surface area now. All right, the other stuff I have slides for, but surface area, the more surface area you have, the more contact you have between your reactants. That's just so there's going to be more collisions between your reactants, right? So more surface area is going to react faster, kind of like when I talked about dissolving, right? When you're going to dissolve a 1 gram cube of sugar versus a 1 gram pile of powdered sugar, that powdered sugar is going to dissolve way faster because lots more surface area, lots more interaction between it and the water that's dissolving it. So same thing with a reaction. The more surface area you have, the faster these things are going to react. And so if you have reactants and you have them all powdered up and mixed together really well, lots of surface area tends to cause a really fast reaction. All right, so now let's get into the nature of reactants. Like, what does that mean? Some things are going to react faster just because they are what they are. So copper reacts with silver nitrate. It produces silver and copper nitrate. Zinc does the same thing. So if I put zinc in with silver nitrate, I get silver and zinc nitrate. It does it faster. Why? Well, zinc's higher in the activity series. Short answer is it's because zinc's zinc and copper's copper. Right? Certain things will just react faster, depending on where they are on the periodic table or where they are in the activity series. So some things are just faster than others. But there's other things that we can do that we can adjust on a particular reaction, and temperature is one of those things. So temperature, remember, that's the measure of the average kinetic energy of a collection of atoms or molecules. Blah, blah, blah. And kinetic energy is 1/2 mv squared. Talked about all this stuff, but it's related to the average speed of the atom. So as we warm things up, things have more kinetic energy. They are moving faster. All right. If they're moving faster, there's going to be more collisions. More collisions. Yes. And more energetic collisions. So the higher the temperature, the higher the average kinetic energy. So they move around faster, so they're moving faster. I'm flying all over the slide. But there's going to be more collisions per second because there's more things moving fast. But they're also going to hit with more force. Bang! All right, because they're moving faster. All right, so there's going to be more of the particles that have enough energy to get over that activation barrier. So that's what temperature does. What about concentration? Also, a fairly obvious one, your concentration, right? If I only have 2 reactant particles here, like A and B, there's only 1 possible collision. If I have 2 of each, now there's 4 possible collisions. Like the more stuff you have, the more possible collisions you could have that would result in the formation of product. So to kind of summon these things up, right? When I increase the concentration, I have more collisions. There's more collisions per second, aka higher collision frequency. There's just a greater statistical chance for a productive reaction. And when I crank up the temperature, right, higher molecular kinetic energy, there's going to be more energetic collisions of the reactants, and more reactant molecules will have enough energy to get over that transition state. Cool. All right, the actual effect on the concentration on rate, we have to do that experimentally. That's coming up later in this chapter. So for example, if I double the concentration, will it double the rate? Maybe. Sometimes when you double the concentration, the rate goes up by a factor of 8, or sometimes it'll quadruple. Sometimes it does nothing at all. We'll get to all that later, but the main point here that you need to absorb is that we need to experimentally determine the effect of the concentration of the various reactants on the rate. That last little chunk here, catalysts. All right, a catalyst. Catalyst is something that speeds up a reaction. It doesn't get consumed in the reaction, so whatever your catalyst was that you had at the start of the reaction, you still have it when the reaction's all over, but it speeds up a reaction. The way it does that is it provides a different pathway. So it doesn't change the the energy of the reaction. So if I have an exothermic reaction that's, say, 350 kilojoules exothermic, it doesn't change that. So it doesn't change the energy of the reactions of the products. What it does is it changes the pathway of how the reactants form the products. And so the uncatalyzed path is like this big snowy mountain. The alternative pathway provided by the catalyst, it's quicker, kind of goes through the mountain. Right, it's a different pathway. It speeds things up. It allows reactions to occur under less harsh conditions. So you might not have to heat it up as high, or you might not need as high of pressure if it's gases or something. So catalysts are very good things. A heterogeneous catalyst is in a different phase from the reaction it's catalyzing, and if it's homogeneous catalyst, it's in the same phase as the reaction it catalyzes. All right, that is that for this section. I'll catch you in the next one.